Recently I was feeling bored and decided to animate a pixel art duck. I was pretty happy with the results until I found this channel, t3ssel8r. My mind was blown. He was able to make what seemed to be procedural pixel art in 3D. I knew this was special because I'd never seen anything like it before. My pixel art duck was cool, but a 3D pixel art duck would be even cooler. As I'm new to game dev, I looked around for which engine to use before settling on Godot. Godot is open source, meaning that anyone can modify the engine to suit their needs. I booted up a new project, and following this tutorial by Lucky, I was able to get a scene with a third-person controller working. I created a 3D node for my main scene, and added a sub-view port to render everything to. Then I added a world environment and a directional light to imitate the sun. Next, I added a 3D node with a camera for a camera rig, and an invisible player controller to handle camera rig movement. I added a plane mesh as the floor, and some mesh instance 3Ds with a few different shapes. I set my camera rig's X rotation to -30 degrees, and updated my player code to lock camera rotation to the Y-axis. Imitating the t3ssel8r style, I set my camera's projection to orthogonal mode. This step is really important in recreating the style. If you don't know, orthographic projection is a way of removing the perspective from the camera's view. To understand this a little bit better, we need to talk about perspective projection first. In perspective projection, the camera defines a box called the frustum. This frustum is used to determine which parts of the scene the computer will render and which parts will be clipped. For perspective projections, the far plane of the frustum is smaller than the near plane. When those parts of the box and everything in it are scaled accordingly, items further away from the camera will appear to be smaller as they would in real life. Orthogonal projection skips this step entirely, with the near and far clipping planes being equal in size. This means that objects in the camera's view will retain their size regardless of their distance from the camera. We want to use this fact to keep items on screen consistently sized, avoiding any unwanted pixel warping. It might surprise you, but the first step to making pixel art is scaling the sub-view port to 640 by 360 gives us this look. So now we have chunky pixels, but it doesn't really look like pixel art yet. There's two things we're missing: step lighting and edge highlights. Let's start with the lighting first, as it's the most simple. Looking at pixel art, you'll notice that the best looking pieces use defined color palettes for shading. I found this Toon Shader online that perfectly creates the effect that we want. It takes the initial lighting and defines threshold values. The lighting is then clamped to the nearest threshold, giving it this stepped, toon-like appearance. This is looking a lot better, but we're still missing those edge highlights to sell the whole effect. And this shader solves that problem. It works in two parts, the outer and inner highlights. For the outer edges, the shader looks at the depth information of a particular pixel on the screen and compares it to its surrounding points. If the difference in depth between the original and each of its neighbours hits a certain threshold, it sets that pixel as an edge, mixing the original colour of that pixel with your highlight colour. Next, the inner highlights. For each pixel, the shader checks the surface direction, otherwise known as the normal, again comparing it to surrounding points. This time, however, it is looking for changes in the angle between normals, like you'd see at an edge or a corner. Calculating the dot product of the original point and each of its neighbours tells us about their alignment relative to each other, with parallel vectors giving a dot product of 1 and perpendicular vectors giving a dot product of 0. This is then checked against the threshold to determine if the pixel qualifies as an edge or not. And now we have a pretty convincing 3D pixel art look. To elevate this even further, we can use the attenuation in the light shader to lighten or darken edges based on their lighting information. To accurately recreate the t3ssel8r look, the next thing we need to tackle is models. t3ssel8r posted this video for showing his workflow for creating scenes in Blender. After creating some basic geometry, he briefly mentions how he uses noise textures in a displacement modifier to create unique, stylized models. For the rocks, we start with the default cube, applying a subsurface modifier to add more geometry. Next, we add a remesh and a displacement modifier with a procedurally generated noise texture. I found that these settings work nicely for the noise, but experiment yourself to see if you can make anything unique. After the displacement modifier, we need to decimate it on planar mode, increasing the angle until it starts to look good. Lastly, we want to use a triangulate modifier to ensure consistent lighting when importing into Godot. Because this is procedural, We can now change the shape of the original cube to create new rocks. Next, I created some simple shapes for pillars and a monument in the middle. We can use the same method as before to create a brick-like texture on other models like these pillars. Using cellular noise instead of Voronoi, we can start to see the bricks taking shape. After arranging everything into place, we can export as GLTF, import into Godot, and apply our shaders from earlier.
Nice.
To bring it all together, we need to add some grass. To do this, we're going to use quad multi-mesh instances. I wasn't able to find any shaders online for this, so I had to write my own. The first thing we want to do is billboard our quads so they're always facing the camera. Now we're going to set the albedo color to match the floor and add a leaf sprite to the albedo texture. This is where it gets a little difficult, as I had to recompile Godot to allow me to access the vertex information in the fragment shader. I set the vertex in the fragment shader equal to the model origin, so that when lighting is calculated, each leaf is shaded based on the light value at its center. This ensures each leaf instance is consistently shaded, which makes it look way better. Now, slowly rotate the leaves randomly based on their world space coordinates to make it look like they're moving in the wind. All that's left to do is add some extra grass with variations in colour and size for visual interest, and that's it. Tesselator style 3D pixel art. And if you're wondering, yes, I did make the duck 3D. If you enjoyed the video, leave a like and subscribe for more in the future.